dilution problems or any problems where solutions are mixed. So when you dilute something, you're watering it down, you're adding water to it. So we've been looking at molarity. Molarity is the ratio of moles to volume, so it's how many moles per liter you have, right? So how many moles per liter are present in a solution. If you dilute something, you're adding more water. So now you have the same number of moles, more liters, you're dividing by a larger number down here. So the molarity becomes smaller. So this section is going to look at problems where the molarity is changing. Either you're adding water to a solution, or you're letting a solution sit out for a long time. The ionic compounds will stay there, the water will evaporate, so the solution becomes more concentrated. Or if you mix two solutions, they each have their own molarity, one will be more concentrated than the other, and when you mix it, you're going to have some concentration in between, right? So in all of the above cases, there are a lot of numbers present, but the easy thing to do with it is you're almost always saying, what's the final concentration? We really care about this ratio. So what's the final ratio of moles to liters? Usually the liters is pretty easy to see. You know, you mix two volumes, you add the volumes to get the final volume. Something's evaporating, you look at the final volume to get the final volume, something like that. So quite often, all you need to do is find out, well, how many moles were in this before I watered it down? Then I'm going to keep those moles because those moles are still there after I add the water, right? So if there's 2 moles of salt dissolved in some container of water, if I add more water, there's still 2 moles of salt in that water. So I just keep the same number of moles, divide by the new volume. So, and in this case, 2 solutions are mixed. How many moles were in this solution? How many moles were in that solution? Add them up, and then divide by whatever the new final volume is. Okay, so let's try that. So in the first one I have 250 milliliters of a 2 molar solution are diluted to a volume of 350 milliliters. So from here, I have a volume and I have a molarity, and I know that molarity relates to moles and liters. So from here, I can either use dimensional analysis or algebra to figure out how many moles of whatever substance there are in that solution, and take those moles and divide by the final volume to get the new molarity. So I'm going to use dimensional analysis because it's probably harder for us. We need to practice it. So I have 250 milliliters. Molarity is dealing with liters. So first thing I need to do is I have milliliters. Let's turn that into liters. So if I have 1 liter, I have 1,000 milliliters. Okay, so I have a quarter of a liter, 0.25 liters. I want to find out how many moles that is. So I can say, and I know I'm writing this out kind of slow to help you get the step-by-step in the beginning of the year, and then we'll pick it up later. So I've got liters, moles will go here. This molarity is the same as if I wrote moles per liter. So there's 2 moles in 1 liter. So I can say there's 2 moles in 1 liter of this solution. Okay, I have a quarter of a liter. There are 2 moles for every 1 liter. So a quarter of 2, I will have 0.5 moles present in this solution. And then I add a bunch of water to it and I get my final volume, 350 milliliters. So I'm going to take my moles and divide by the 350 milliliters. But I'll turn the 350 milliliters to liters. You can see to go from milliliters to liters, you divide by 1,000. You can always set it up like this. Or when you're dividing by 1,000, you can also say, well, the decimal point is originally here. I'm dividing by 10 3 times, right? So I'm dividing by 1,000. That's 10 times 10 times 10. 10 times 10 is 100. 100 times 10 is 1,000. So I'm dividing by 10 3 times. And every time you divide by 10, the decimal place moves over. So, okay, so it ends up there, 0.350. So the final molarity is going to be 0.5 moles per 0.35 liters, which gives me 1.492. Is that right? Yeah, 1.429 molarity. And then looking at significant figures, there's 2 here, 2.02 there, 2 there. I'm going to give this 2. So 1, 1.4. I won't round the 4 up because 2 is less than 5, so this is closer to being 1.4 than 1.5. 1.4 molar is my final answer. We'll look at another one. I have 150 milliliters of a 2.2 molar hydrochloric acid solution are mixed. So I mix these two. From this information I can find the moles. Are mixed with 25 milliliters of a 1.0 molar solution. I can find the moles again. What's the final molarity? So I'm going to take the moles from each of those, add it up, and divide by the final volume, and that will give me the new ratio of moles per liter. Per means divide, by the way, so whenever you see that fraction sign or you hear per, you're dividing. So I have 150 milliliters, so I'll do dimensional analysis one more time. Some more practice. It's good. It's how we get good and remember. So I've got milliliters, so milliliters goes down here. I'm going from milliliters to liters, so for every 1,000 milliliters, there's 1 liter. Going to change it up on you this time and continue my dimensional analysis. I have liters here. I'm looking for how many moles are present in this 150 milliliters of 2.2 molar solution. So this tells me there's 2.2 moles for every 1 liter, right? Because it's moles per liter. So there's 2.2 moles for every 1 liter. Okay, so milliliters to milliliters, liters to liters. I'm left with moles. So I'll go 150 divided by 1,000, then times 2.2, and I end up getting 0.33 moles. So that's how many moles are present here of hydrochloric acid. Let's see how many moles are in that. I have 25 milliliters. So the unit I have is what goes on the bottom, milliliters. I'm converting it to liters, and if I have 1 liter, I have 1,000 milliliters. My new unit is liters. So the unit I have goes on the bottom. I have liters. I'm looking for moles. That's what we're doing here. How many moles are in that second solution before we mix the two, right? So I'm going to go from liters to moles, and the thing that relates moles and liters is molarity. 1.0 molar means 1 mole for every 1 liter. That's convenient. So 25 milliliters divided by 1,000 times 1, I end up getting 0.025 moles. So I have the moles from this first solution, moles from this in the second solution. So I have 0.355 moles total over the total volume. And the total volume, moles per 25 plus 150, that's 175 milliliters. I'm going to go ahead and just divide, just going to take that 175 milliliters and move the decimal 3 times. My carpool's ready to go, speeding up, sorry. So there's 0.175 liters. Okay. So that many moles divided by that many liters gives me a molarity of 2.0286, right, moles per liter, or molarity. Looking at sig figs, I have a habit of writing 2 sig figs and things. I'll try not to do that, it's too easy. 2.0 molar is my final answer. And we're done. Sorry, Carl.